Checkpoint 2. Here are the equations of the three waves. The first equation, y of x comma t equal to 2 sine 4x minus 2t. And the second wave equation, y of x comma t, which is equal to sine of 3x minus 4t. And then the third wave equation, y of x comma t, which is equal to 2 sine 3x minus 3t. Rank the waves according to their wave speed and maximum speed perpendicular to the wave directions of travel. That means the transverse speed. So the greatest first. That means we have to give the answer from the greatest point. Clear? So here I have to first write the wave equation. So before I write the given three equation, let's we write the general form of the wave equation. So what we studied from the theory, the general form of the wave equation is given by y of x comma t, which is equal to the amplitude of the wave multiplied by sine of kx minus omega t. So here the amplitude, but in the book they mention as, in place of a they mention ym. Clear? So that ym nothing but the amplitude. Clear? So now we have to compare these three given equation by the general equation. Clear? So that means a represent the amplitude, k represent the angular wave number, and omega is the angular frequency. And by using this wave equation, we can easily find the wave speed, because the wave speed formula v, which is equal to frequency multiplied by lambda, and the formula for the frequency was generated from the equation omega, because omega we know, which is omega, which is equal to 2 pi f. Therefore frequency, which is equal to omega over 2 pi. And also we know the concept of, we already studied the concept of lambda, which we took from the equation the angular wave number k, which is equal to 2 pi over lambda. So from this we can easily find the lambda value. So lambda, which is equal to 2 pi over k. So when you substitute these two equations in the general equation of v is equal to frequency multiplied by lambda, we got frequency, which is equal to omega over 2 pi multiplied by 2 pi over k. So 2 pi get cancelled. So we can easily find the answer for the angular speed as omega over k. So now what I am going to do, I am going to use this equation in the three given wave equation. And by applying this value of omega and k, we can easily find the wave speed. So let's we write the first equation. What is our first equation? Y of x comma t, which is equal to 2 sine of 4x minus 2t. And then the second equation here is y of x comma t, which is equal to sine of 3x minus 4t. And then the third equation here is y of x comma t, which is equal to 2 sine 3x minus 3t. Clear? Now what I am going to do, I am going to find, because we have to find the wave speed, and also we have to give the answer from the greatest. That means greatest, second greatest, and the last ones. So let's we apply this rule in the first equation to find the wave speed. So what's the answer? So here when you apply the wave speed here, v, which is equal to omega over k, where omega, so here omega is 2, right? So 2 divided by 4, that means 2 over 4, which is 0.5 meter per second. And then let's see what is the wave speed for the second equation. V is equal to omega over k. So here omega is 4 over 3, which is equal to 1.33 meter per second. And then from the last equation, V is equal to omega over k, where omega here is 3 and then k value is 3. So 3 over 3, which is nothing but 1 meter per second. Now we have to give the answer from the greatest. So which one is the greatest? 1.33. That means, let's we take, this is V1, this is V2, This is V3. So three waves we have. That means V2 is greatest. So V2 is greatest. And then V3 is the second greatest. And the last one is V1. So this is the answer for A part. Clear? Now we have to find the maximum speed. That means the transverse speed we have to find. So for that, we have to take the first order derivative of the wave equation. I hope you understand the answer for the part A. So now we have to go to the second part, which is we have to find the answer for the transverse speed. So for transverse speed, first we have to identify the transverse speed by using the derivative of the wave equation. So let's we find, so this is our wave equation, y of x comma t, which is equal to amplitude multiplied by sine of kx minus omega t. So therefore, so transverse speed, let's we take the letter u. So u, when you find the derivative, which is dy over dt, when you find the derivative, so this becomes a amplitude as it is, and then the sine is nothing but cosine of kx minus omega t. When you find the derivative of this term, which is minus omega, so when you rearrange this equation, minus a omega cosine of kx minus omega t. So this is the answer for this is the main equation for the derivative of the wave equation. But the transverse speed we have to find, we have to take the magnitude of the first part, which is minus of a omega. So that means if you take the magnitude, so this will give the answer for the transverse speed. Transverse speed. So when you take the magnitude, which is a multiplied by omega. So we have to apply this rule in this three given equation. So again, I have to write the equation 1, 2, 3. So let's write the first equation here is y of x comma t, which is equal to 2 sine 4x minus 2t. So later on we will confirm the equation is correct or not. And the second equation here is y of x comma t, which is equal to sine of 3x minus 4t. And then the third equation, the given third equation is y of x comma t, which is equal to 2 sine of 3x minus 3t. So let's we confirm 2 sine 4x minus 2t, 2 sine 4x minus 2t, 4x minus 2t, right? Then the second one is 3x minus 4t, sine of 3x minus 4t, correct? The third equation is 2 sine 3x minus 3t. I hope all these three equations we wrote correctly, right? Now I have to apply this rule. So let's we take the first equation. So in the first equation, I'm going to find the transverse speed. So I represent u as the transverse speed. So u1, which is equal to a multiplied by omega. What is a? Here a is the amplitude. So amplitude value is 2, and here omega value is 2. So 2 multiplied by 2, we got 4 meter per second. And then second equation u2, which is a multiplied by omega. So a here is 1 because it says 1, and then omega value is 4. So 1 multiplied by 4, which is equal to 4 meter per second. And then u3, which is a multiplied by omega. So 2 is the amplitude and 3 is the omega, angular frequency. So 2 multiplied by 3, which is 6 meter per second. So now we have to say which is greatest first. So that means u3 is greatest, but u2 and u1 have the same value. So we can write u2, which is equal to u1. So this is the answer for the part B. I hope you understand the second part. That's it. Thank you.